So we only went through half of 4.4. The book puts a lot in this section. I would have broken it up. But we're going to talk about the mean value theorem and then the average value of function over a closed interval. So there's our academic standards. What is the mean value theorem for integrals? So let's see if we can understand this. So I have a curve. And isn't the area under this curve from, you would take the antiderivative from A to B. Would everybody agree with that, right? Somewhere, though, look at this. I could treat this as a rectangle. So look how I went B minus A times there's somewhere along this curve that value C where f of C, so the f of C is the height times this width. That area of the rectangle is going to be equivalent to that area under the curve. Notice how these two match. So that's what they're saying by the mean value rectangle. So I want you to look at this. B minus A is my width of my rectangle. F of C is the height of my rectangle. It's somewhere along the curvature where this equals the antiderivative from A to B of f of x d of x. Okay? I'm going to give you the theorem here in a second, guys. That's this, the mean value theorem. So somewhere along in the curvature from A to B, f of x d of x, that's equivalent to the height somewhere f of C of B minus A. If you remember, we did mean value theorem already this year, where we said the slope of the secant line will be equal. There is a point C where the derivative equals the slope of the secant line. This is the same thing, except in terms of the antiderivative. Okay? You're going, how in the world is that the same thing? I want you all to think about the antiderivative of f of x, and then I'll show you what we're going to do here. I'll just wait. So you got that written down? Because we're going to take this and apply, oh, okay, I'll go back. Sorry. And I want you to remember f of C, this right here, f of C, that is the height of your rectangle, and B minus A is the width. Maybe you want to make that note in there too. Okay.
I'm sure this is the most fun sick day she's ever had.
Mr. Dice, did you read when you were sick?
Yes.
Oh, no, you didn't.
I did. Here's the average value. So look what I did. I took that B minus A from the, look, if you look previously, I took this B minus A, and if I divide by B minus A, it becomes this, guys. It becomes 1 over B minus A from A to B of f of x d of x. So what is this? This is the value of f of C given in the mean value theorem for an integral is called the average value of f. It finds the average point along the curve. This equals the height.
That's Mr. Dice.
Mm-hmm.
That is just...
This is the average value. Yes. It's the average height.
I've seen worse.
Really?
Nate's experience worse. I've experienced worse, but I've seen.
What's the worst experience? What's the worst you've seen?
I mean,
See, notice that? That f of, so you guys see how that works? This f of C, if I divide by B minus A, and I go back, this is F of C. This equals F of C, which is the height. F of C is the average. Notice in the previous one, Abby, I don't have that integral. I tell you the integral from a to b f of x d of x is equal to f of c times b minus a. If I said solve, if I say divide by b minus a, which is the same thing as 1 over b minus a, right?
Yeah.
See how this equals that? Look at this.
Oh. Yeah.
F of c is the average value. If I go all the way back, which I can't. Yeah, I can. Boom. If I go all the way back, F of C was the average. There's a point until it found it for me. Okay? And here's the theory behind it, which I'm not going to make you do anymore. You guys don't have to do that. You guys did a better job on the test, by the way, than a lot of my classes of doing that last one with the sigma notation. Now, a couple of you, one of you did, Gabe, I think it was you, you did voodoo math at the end. You knew it was supposed to be 5/3, and you had 2 plus a third, and all of a sudden it became 5/3. So, yeah, so if I say find the average value of this function on this interval, I'm gonna set this up just like this. 1 divided by 4 minus 1 is 3, so 1/3 from the integral 1 to 4 of 3x squared minus 2x d of x. And you're just going to take that, you're going to say 1/3 times, you're going to take the antiderivative of 3x squared, which is x cubed. You're going to take the antiderivative of minus 2x, which is x squared from 4 to 1. You're going to plug in the f of 4 minus f of 1. And you're going to end up with 48/3, which is the average value. Okay. And if we can see this, the average value is 16. This height is 16, which is, didn't I tell you that was the f of c, the height of the rectangle? Okay. Net change theorem. So we understand from the fundamental theorem of calculus states that the integral from a to b of f of x d of x takes me back to f of b minus f of a. But because f prime of x, look at this, capital F prime of x is equivalent to f of x, I want you to think of it this way. Look, the antiderivative, this is what I had you thinking of on the graph. The antiderivative of the derivative takes me back to the original function b minus f of a. So I want you to think of it in terms of velocity, guys. The antiderivative of velocity, which is the derivative, takes me back to position b minus position a. So that's what we mean by net change, position minus position. Okay? But then you write this down, the net change, the antiderivative of f prime x d of x, and I'm going to add to that to help you guys the integral of velocity of t d of t from a to b is equivalent to, what's the antiderivative of velocity? Position b minus position a. And then what I'm going to do is I'm going to take the antiderivative of the absolute value of velocity, and that'll tell me total distance traveled. Because isn't the absolute value of velocity, whether I'm moving left or right, it's always going to put it above the x-axis. So instead of drawing the schematic and counting the total distance traveled left and right, we're just going to take the absolute value of velocity and take the antiderivative, and we can do it. So, let's talk about net change. A chemical is flowing into a storage tank at a rate, and I give this to you, of 180 plus 3t liters per minute. Notice how it says liters per minute, because that's a rate. Derivatives are rate, where t is the time in minutes from 0 to 60. Find the amount of the chemical that flows into the tank during the first 20 minutes. So all I'm going to do is I'm going to set it up where I'm going to take from 0 to 20. Of that, I'm calling that rate 180 plus 3t. So during the amount that flows into the tank is from 0 to 20 of 180 plus 3t DOT. You're going to be, you can't go, it's a story problem, not paying attention to it, bullcrap. I'm going to continue throwing these at you. Okay, one of your open-ended take-home quiz questions has to do with rate of flow. So I take the antiderivative, I plug in upper minus lower. So the amount that flows into the tank during the first 20 minutes is 4,200 liters. Think about it. That was represented by the graph that we were doing. The rate is the graph that we were doing. We were taking the antiderivative of the rate, takes me back to amount, area under a curve. So I had you already write that down. And then we can take total distance traveled. If you want to add that to it, would just be simply from A to B, the absolute value of VOT DOT. Look at that. This distance, don't we break it up? What we do with absolute values when it goes below the x-axis, we say minus to get this negative area back to positive plus the positive. We did this on the test, didn't we, guys? We negated the negative part. We made it positive. So I said the area from here to here plus the area from here to here plus the area from here to here. You have a 4.4 web assigned assignment. There's like 12 or 13 problems.